Hello, this is Britjet's PSX Tips, the Aerowings PSX 747-400 desktop simulation, and today I'm going to be talking about VNAV, specifically in the climb and cruise. This is the first of two videos. The next one will be for the descent phase, and I'm bringing these in now to make sure everyone understands the various VNAV modes before I do non-precision approaches. This will also be mainly about tips and gotchas, things that can go wrong, rather than a full overview of the VNAV profiles, because I think most people understand that. Now in this section I am just talking about climb and cruise. There will be some slight differences for the descent and approach phase. They will be in the next video. After takeoff at 400 feet the VNAV will engage and you will see VNAV speed. This means the auto flight system is flying the speed using the elevators, and the thrust will typically be thrust ref. So this means, quite simply, the aircraft is climbing. The next thing you're likely to see will be either this or this. What's the difference? Okay, let's go back to this one. If you see VNAV path, it means that the aircraft has leveled off and the level it's at is in the legs page. It doesn't necessarily have to be in the alt cell. Just what is on the legs, it's flying the path it sees in the flight system. Now if you go over to the other one, which is VNAV alt, what that means is the aircraft has leveled off at something that is not in the legs page, which means that it is looking at the alt cell, the altitude in the mode control panel. And I've done this in orange just to emphasize that this is something that quite often needs us to pay attention to, maybe something that we need to change. Has everybody got that? Yes, I thought so. I've set the sim up just having taken off, it's retracting flap, and I've invented a departure in the FMC with some step climbs. You will see that the first step climb, CPT-03, has a 220 knot speed restriction in it. So one thing we can do is air traffic control make it simple for us by saying climb unrestricted. How can we do that? Well, one way is to do it through the FMC. So let's suppose that air traffic control clears unrestricted to 6,000 feet with no speed restriction. So 6,000 feet goes in the alt cell, and I can now use a thing called climb direct. And if you look on the right hand side of the FMC there is a button for climb direct. Now if I select that and you watch the legs page, you will see it deletes everything up to 6,000 feet. And if I decide I want to go ahead and execute it, all my constraints, all the bits on the legs up to 6,000 feet have disappeared. The slight disadvantage of that is you have to go down into the FMC to do it. And of course the other thing you can do, of course, is delete or amend any line at any stage. That depends on what sort of departure or indeed arrival you're flying, but if I put delete in there, obviously I can delete the first waypoint if I wish, that simply. Of course in this case that would also take out the speed restriction. I can obviously delete selectively like that, but that involves going heads down in the FMC, which is not always a good idea. Another system that we can use is actually called alt cell intervention, or if you prefer, simply pushing the alt cell knob. This is a little bit more refined and we don't have to look into the FMC to do it, but you do need to understand what it does. So every push of the alt cell will delete constraints provided the alt cell is above the constraint. So in this case we've got 3,000 feet in the alt cell and we've got 3,000 feet in the FMC. In this case nothing will happen if I push the button, and I'll just demonstrate that. Okay, there we go, I push the button, nothing happens. But if I change the alt cell to a higher altitude, say 4,000 feet, and I push it, watch the legs page, and you'll see it's just done one of the constraints. If I push it again, nothing will happen because the next constraint is 4,000 feet, which is the same. So I'm pushing the button, nothing happens. But watch what happens if I set 12,000 in, for example. Now every time I push the button, it will delete those constraints up to but not including 12,000, like this. So one push, another push, another push, and one more push won't do anything. So that's the use of the Alt Cell button. Okay, let's fly a SID with our imaginary step points, and let's suppose air traffic control are going to give us different clearances which we've got to adhere to. The first clearance they give us is to maintain the speed restriction but climb to only 2,000 feet. So let's let that go. We've put 2,000 feet in the Alt Cell, and I'm bringing in the flap as we accelerate, so we're just concentrating on the VNAV. You'll see 220 knots has been bugged on the speed by the FMC, and in a moment it will go to VNAV Alt. You'll notice, of course, I can't do a complete cleanup here. So there's our VNAV Alt. Now if ATC then tell us to climb to 4,000 feet but maintain the speed restriction, we've got a bit of a problem here, because if I want to push the Alt Cell, it will delete 220 if I want to go to 4,000 feet. So there is a way out of this, and one is to push the speed window and open it at 220 knots, and then put 4,000 feet in the Alt Cell and push the button. The aircraft will now climb. It's deleted the first leg, but you have intervened the speed on the speed window. And all you're going to do is manually close that speed window when you pass your speed restriction point, which is CPT 03. So that's going well. We're going to level at 4,000 feet, which is in the FMC, so we expect to see VNAV path. There it is. Just move things on a bit faster on the speed up. Once we pass CPT 03, I can close the speed window. The aircraft will now start its acceleration. And let's suppose, for the sake of argument, ATC tell us to climb to 5,000 feet. You've got to be careful here, because 4,000 feet is still in the FMC ahead of you. And if you do nothing, the aircraft will stay at 4,000 feet and you'll annoy air traffic control. So we notice that, and we are going to push the button. Off we go, and the aircraft will climb and delete that constraint. Okay, so far. We've cleaned the aircraft up, and we're going to 5,000, and again we will get to Alt Cell. Sorry, to VNAV path. Now suppose, for the sake of argument, that ATC tell us to climb to 7,000 feet now. We can start that off like this. And again, because we haven't passed our 5,000 foot point, we will need to push the button. And as we leave 5,000 feet, air traffic control say, our mistake, stop climb at 6,000. So we'll put the 6,000 in the Alt Cell. Now we are going to be leveling off in VNAV Alt because it's not in the FMC. Now, you remember that VNAV Alt was written in orange on the presentation. The reason is, if you see that, it always means it's probably asking you to do something or expect something to happen. And usually you have to do something. So let's suppose now they say, right, up you go to 7,000 feet. So ATC clear us to 7,000. 7,000 is ahead of us, but because we're in VNAV alt, the aircraft will not climb until we push the button. So I'm going to push the button again, and up we go. So the danger always is being in VNAV path at a lower altitude and the aircraft doesn't climb to the ATC altitude, and the other danger is the aircraft is in VNAV alt and won't climb because you haven't pushed the button. That is not to say that pushing the button is always the fix, because as you've seen, it will delete leg constraints. Just to prove that the system will work fully automatically, we'll now put 12,000 feet in the window as it levels off here in VNAV path. The aircraft's levelling off nicely, and I'm going to speed it up a little bit towards Compton to save time, because I'm sure most of you want to go to the pub. So as we approach CPT, I will slow it down again, about there. So what do you expect to happen when we go over the top? Well, it's in path at 7,000 feet. Its next path will be Kennet at 12,000 feet. So we're hoping it's going to climb without anything from us. And there you go, VNAV speed. The aircraft will now climb to Kennet at 12,000. As we approach 10,000 feet, we have a choice here. Do we want to use Econ or do we want to use our own cell speed? I've gone for my own cell speed, and as we go through 10,000 feet, then of course the aircraft will accelerate. One little trick here, if somebody asks you to expedite the climb, a couple of things you can do. Well, obviously one of the things is to select full climb power on the thrust limb page, which is a little bit outside what we're talking about today, but I'll do that anyway. The other thing is to bring the speed back to, for a good rate of climb, about the up bug or the min maneuvering bug if you prefer, plus 20 knots. So in this case it would be about 260. So I can put this in the FMC, and suppose they said good rate through flight level 140, so I can go 260/14,000 in this case, and put it in the speed restriction page, and if I execute that, the aircraft will now come back to that speed until it passes 14,000. The other way of doing that is actually just to intervene the speed on the MCP, which is just as useful. It's just that this way actually reminds you to cancel it, because it will do it automatically. As we'll see here, as we come to 14,000 feet, the aircraft will go back to my cell speed request of 290 knots. There it goes. We've levelled off at our air traffic control assigned altitude of 32,000 feet. Are we in the cruise yet? Well, there's a little hint on the nav display which is showing that we have the top of climb still ahead of us. A little trick for knowing what mode you're in is press the VNAV button on the FMC once. This will be particularly useful when you're using the non-precision approaches. So press VNAV once and it tells me immediately that I'm actually still in climb mode, which means that I'm actually at my climb speed. Now I've got 290 knots here, but if I go to next page and select cruise, I actually really want to be cruising at 0.85. So I have to get from climb mode to cruise mode. The easiest way to do that is actually to put 320 in the FMC like that, and the aircraft will go to 0.85. Now we've still got VNAV alt. Orange writing, remember? Let's try and get that to path. The best way to do that is to come out of VNAV and then go back into it again. So I'll press altitude hold, that will do it. Comes out of VNAV. It will open the speed window, of course, and then I press VNAV again, closes the speed window, and I'm now in VNAV path. So that's how to sort out a situation when you've become in VNAV alt near to your cruise altitude. We're in the cruise now at 320 in VNAV path, and we want to know what our optimum altitude is. Well, it's 342 at 0.82 Mach in this case. We've been asked to slow up. Our maximum altitude will be governed by the speed we fly at, and in general 0.86 will give you your maximum altitude. They always say the 747 has a 0.86 wing. So I've got 377 as my max altitude at the moment. If I put 0.86 in, watch what happens to my maximum altitude. Another 1,000 feet. And it's an interesting tool that you can use sometimes to get a little bit higher if you need to achieve an air traffic control clearance or for some other reason. So that's basically all I'm going to talk about with climb and cruise modes, and the next video will be on descent and approach modes.